Hey, we're looking at section 8.4, angles of elevation and depression. So really looking at two new vocabulary terms to kind of work into your frame of reference for when you're solving any type of problem involving trig ratios and right triangles, okay? So we have here a very hyper-realistic animation of a plane flying over a control tower and illustrating angles of elevation and angles of depression. An angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the horizontal line. An angle of depression is an angle formed by a horizontal line and a line of sight to a point below the horizontal line. So going back over here to our hyper-realistic drawing here, the people in the control tower, if they look at the horizon just straight ahead, that forms a horizontal line, okay? So look straight ahead, horizontal line. To look at the plane, they have to look up above the horizontal. They have to elevate their head. So that forms an angle of elevation. The pilot looking straight ahead, that forms a horizontal line. The pilot to look down at the control tower has to depress their line of sight to look down. So the angle formed between the horizontal, if they're looking straight ahead, and then down. So an angle of depression. Now something to note is that both the people in the tower and the person in the plane have horizontal lines if they look straight ahead. Both of those horizontal lines are parallel to each other. So angles of elevation, angles of depression, if the two objects you're comparing them, angle of depression for one to the angle of elevation for the other, those are alternate interior angles. They will be congruent. So again, here is one classify each angle as an angle of elevation or an angle of depression. Go ahead, fill that out, pause the video, check what you have on the completed notes, then start the video back up, and we'll do example 2. So example 2, a plane is at an altitude of 3,500 feet and the angle of elevation from the airport to the plane is 29 degrees. So first we need a visual. So I'm a really good artist. And there's my plane. Oh, that thing's gonna fall out of the sky so fast. Oh, so I'm a good artist, right? Attention to detail. There we go. Looking much better. Alright. Thank you for your high praise of my artistic skills. So let's draw an airport. Airports have runways. They have control towers. It's like some kind of really bad UFO. And the window panes. Looks a little like the Space Needle in Seattle. Wow. And the terminal. See? Airport. You can tell. Now the altitude is 3,500 feet. So 3,500 feet. the angle of elevation from the airport to the airplane. So getting that line of sight. Then we have the horizontal also. And that angle in there is 29 degrees. Alright. So now so this drawing is only given information that we got. Okay, so just taking the writing, making a visual out of it. What is the horizontal distance? So the horizontal distance. So we're trying to find x. Well, look at the picture you have. Does that picture lend itself to sine opposite over hypotenuse, cosine adjacent over hypotenuse, or tangent opposite over adjacent? So I think from this drawing, really lends itself to tangent opposite over adjacent. So tangent of 29 degrees is going to be opposite 3500 over adjacent x. Now when you have the variable in the bottom of the fraction, you can do the switch, because you're going to divide multiply x over, then divide tangent 29 back to the side. So we're kind of switching those two. So x is 3500 over tangent of 29 degrees. They say round to the nearest foot. And using a calculator, that round to about 6,314 feet. Alright, so little new vocabulary, angles of elevation and depression, then incorporating that into everything we already know with SOHCAHTOA and right triangle trigonometry. So take a look at the other two. Check your answers with my completed note online.